Good.
Good.
Now, I'm just going to say something. If at some point when you're working with sinusoidal functions, they're going to want you to go the other way. In other words, they're going to show you the graph and want you to come up with the equation. When you get to those problems, the best way to deal with that, because you can't really verbally describe the graph, but you need to take a picture of those with your cell phone and send them to my email. And then I'll be able to bring those up on our screen, and we'll both be looking at the graph, and then we can figure out how to come up with the equation of the function.
Okay.
Okay? I don't know if they've asked you to do that yet or not, but I don't believe you and I have been through the process of you sending me a picture yet.
Not yet.
So that might be something good to do, because the first time you'll have to type out my email address. The second time you should just have to type out the two first letters.
Okay.
Okay. So what are we going to do today? Are we doing more sinusoidal stuff?
Actually, no. Today,
Okay.
I need to go over, like, pretty much like quadratic equations. Like, for example,
Okay.
I have 3x squared plus x minus 4 equals 0. And it says determine the factors.
Okay. Well, it's always worth trying to factor it, unless you can immediately tell that it can't be factored normally. In other words, there's two choices. Either we can factor it normally, or we have to use the quadratic formula. Okay? Let's give it at least one shot to see if we can factor it normally.
Okay.
Split up the 3x squared. What has that got to be? Here and here.
3x and x.
Okay. It's the first step. That's a given. If there's a solution this way, that's a must. What are my signs? Both signs.
Both of them will be negative.
No, we wouldn't be able to produce. We wouldn't be able to produce that if they were both the same.
Yeah, one will be a plus, one will be a negative.
Okay. And sometimes plus minus is the same as minus plus, but if the coefficient of the x term is not the same, then plus minus is not the same, and we have to consider both possibilities.
Okay.
Now we want factors of 4. And it becomes a trial and error. Here's the factors of 4. So we got those two possibilities.
I would pick 4.
I can kind of see right off the get-go that if I put a 4 here and a 1 there, that's going to produce the proper coefficient of the middle term.
Yes.
The 4 needs to be with the plus, and the 1 needs to be with the minus. So now I erase the alternative, and whenever I've factored a quadratic, I know that the first term's going to be right and the last term. I don't really need to check that term, and I don't need to check that term. I know those are correct. But the middle term is the one that's always the one that may or may not be right. And you get the middle term by multiplying the insides together and the outsides together, and then adding the result. Well, that gives me my middle term. I did it right.
Okay.
What's the solution? What are the zeros?
Minus 4 and plus 1. Or minus 4 and 1.
It's actually
no.
4 over
3. Yeah, 4 over 3.
In other words, we set this equal to 0 or that equal to 0, and we solve each of those equations. Okay. Yeah, be careful with that one, because a lot of people tend to think that it's just the opposite sign of this is the answer. But if there's a coefficient in front of the x, it's not.
Okay.
If it's always a 1x like this, then the answer is always the opposite sign of that number.
Okay. Then I have another one.
Okay.
So x squared minus 4x plus 13. And so it says solve the equation using the quadratic formula.
Yeah. It's pretty easy to tell that this is not going to factor properly because 13 is prime.
Yeah.
So there's only two factors for 13, 13 and 1. And those are not going to produce a middle term of minus 4x, I know immediately.
True.
So there's no point in even wasting time trying to factor it. Let's just go straight into the quadratic formula. What is the quadratic formula? What's the general quadratic?
X equals negative b, and b squared minus 4ac all divided by 2a.
Don't forget the plus or minus. And the whole thing's divided by 2a. So let's fill it in. What's minus b?
That'll be 4.
The rest of it?
16 minus.
I really think that you can do yourself a big favor here and always write it out. Never try to figure out what that quantity is in your head.
Okay.
Even though it looks simple, the chances of dropping a negative sign are huge. So let's write it out exactly as we see it. 4 times a, which is 1, times c, which is 13. Okay? And now over 2. And now what we're going to do is multiply those three numbers together before we do another step. Well, that's 52. So we have 16 minus 52. That's minus 36. And now we can proceed.
Okay.
What's the next line? Let's do it step by step. 4 plus or minus. What's the...
6i.
Good. Now, what's the next step?
Then the 2, the 4, and the 2 can be crossed out.
Divide top and bottom by 2.
That'll be 2 plus or minus 6i. I mean 3i. Yeah.
Right.
Yeah,
So there's your final answer. And it's important to realize what that means. What it means is that I have two answers. There's one of them, and here's the other. And just for your information, complex answers always come in pairs that are conjugate of one another. If I told you that one solution to a quadratic was 2 plus 3i, you would immediately know that there is a second solution that is 2 minus 3i.
Okay.
They never come alone. You're never going to have an imaginary solution that's just that. And you can see why, because that plus and minus. That plus and minus is always going to give you two different solutions, one being the conjugate of the other.
Okay.
Okay. What else?
Another one I have is number 3. Okay. So for this one, it is parenthesis 4 plus I, close parenthesis, then 4 minus I, and then another parenthesis, 2 plus I.
Okay. We're going to FOIL all three of these together. That's all we're going to do. There's no secret to this. You know, do they teach you FOIL in Florida? FOIL?
Yes.
Okay. However, there is a shortcut here. Notice that that is the difference of squares factored, right?
Mm-hmm.
A squared minus B squared is always A minus B times A plus B. And whenever you see this, it's worth noting that you're looking at the difference of squares factored, so to put them back together again is real easy. It's that squared minus that squared.
So 16 minus I squared.
Uh-huh. And what is I squared?
That would be 1, or negative 1.
So it's 17. Right?
Yes.
Times 2i plus 1. Now I don't even have to FOIL it, I just have to distribute it.
So 17, that would be 4, 34. And then 17. Yeah, wait.
17.
17i.
I forgot to put a dot over it, made it look like a 1.
Oh, okay.
That's a common problem whenever you're using some of these letters. It's like I hate when they put equations that have both Q and G in it. Have you ever seen anything like that? Where they'll have Q equals G times R times 2, something like that.
I have a question. Is I squared a negative I, or a negative 1, or just
Negative 1. Here's how it works, and this is important to see. In other words, I squared is I times I, right?
Yes.
So square root of minus 1 times square root of minus 1 gives you minus 1. And then I cubed is I squared times I, so that must be minus I. And finally, I to the fourth is I squared times I squared, that's plus 1. And now it starts all over again. In other words, there's only 4 unique answers. Every other I to a power is, in other words, that's I, that's minus 1, that's minus I, that's 1. So what's I to the 24th?
1.
Correct. What's I to the 26th?
Negative 1.
Correct. In other words, you divide the exponent by 4, and whatever remainder you have, that's the exponent of I. It's the same as I squared. And, I mean, that may seem a little arcane, but this is a very common question on the ACT test. They'll do this. What is that?
Negative 1.
Negative I.
Or negative 1.
That's the same as I to the third. In other words, when I divide that by 4, my remainder is 3. So it's I to the third, which is negative I.
Okay.
But the main one that you always have to convert is I squared. In other words, whenever you do any math with imaginary numbers, you end up with a lot of I squareds. And the beauty of I squared is that it changes into a real number. It goes from an imaginary number to a real number. And like if I'm multiplying, say, 3 plus I times 2 minus 4I, and I'm going to FOIL those two together, well, I don't end up with any I cubes or I to the fourths, but I do end up with an I squared. And I end up with a bunch of I's. Well, now I can't do anything with the I's, but if I FOIL those two together, I get 6 plus, well, excuse me, 6 minus 12i plus 2i minus 4i squared. Well, that's going to turn it real. That's plus 4. So my final answer is 10 minus 10i. In other words, I almost never have to deal with I cubed or I to the fourth, but I frequently have to deal with I and I squared. Can't do anything with the I, but I can do a lot with the I squared.
Okay. The next one I have is 5x squared plus 30 equals 0.
Okay. Immediately, I recognize this is not a normal-looking quadratic. It's missing the x term.
Mm-hmm.
When I am missing the x term, I don't need to solve it like a normal quadratic. Okay?
You just subtract the 30.
Well, I'm going to, hold on one moment. I'm going to take the 30 and put it on the other side. In other words, normally when you solve quadratics, you leave 0 on the other side and you factor the left side. But this left side doesn't factor all that great. But what happens if I take the 30 to the other side?
5x squared equals negative 30. You can divide both sides by 5.
And now what?
Square root.
What's the answer?
X equals 6, or square root of, or plus or minus.
Ah, beautiful. You're 1 in 100 students. And I'm not kidding you. 99 out of 100 students would forget the plus or minus. And what I try to teach them is that every time you solve an equation by taking the square root of both sides, start your answer with plus or minus. I wish that was a song that I could teach, because everybody forgets it. So it's this, and then what does that convert to?
There's an I.
Well, what's the final answer? Plus or minus what?
6i.
No. Let me show you how to do this. Square root of minus 6. Whenever you have the square root of a negative number, always turn it into the square root of 6 times the square root of minus 1. In other words, always take out that minus 1, because we know what that is. That's I. And so the answer is square root of 6 times I. Okay? But if you always do this step, you will never have the problem that you encountered. In other words, there will never be any doubt in your mind as to what it is.
Okay.
Okay? And both of those answers are legit. In other words, when you have a quadratic, always expect 2 answers. If you only get one answer, it's the rarity, not the common. Almost always you have 2 answers. And so had you forgot the plus or minus, you would have ended up with only one answer, and that was the square root of 6i. And you should start asking yourself questions when you end up with one answer, particularly if it's an imaginary answer, because we know those always come in pairs. So you would never, ever end up with one answer that was imaginary. That's basically impossible. So if you were to get this, you should say to yourself, well, I'm missing an answer. I forgot the plus or minus. Okay. What else, Taylor?
I have another one. 6x squared plus 12 equals 0.
Okay. What's the next line?
Minus 12. So then it would just be 6x squared equals negative 12. Divide both sides by 6. X squared equals negative 2. Then it will be x plus or minus square root of 2 times I.
Good. And we usually always put the I afterwards. In other words, we have a coefficient in front of I. And the only thing you have to be a little careful with here is make sure that radical sign doesn't go all the way over, because the I is not under the radical. And yet, in other words, if I really was a stickler, I'd want to put the I in front, right? Because then there's no possibility of confusing it. But that's not what math does. Math puts the coefficient in front of the I. In other words, the standard format for a complex number is a plus bi. So the b is in front of the I. So whenever that b is a radical, be careful you don't make the radical go too far to the right.
Okay.
You're jumping all over the place here between trig, sinusoidal functions, imaginary numbers.
Yeah, it's because yesterday I was trying to review for my final, but then today I have a test tomorrow on this stuff.
Okay.
So I have another one.
Okay.
5x squared minus 19x minus 4 equals 0.
Minus 4.
Yes, equals 0.
Now, whenever I see a quadratic like this, I say, okay, it's worth about 2 minutes of my time to see if I can factor it. And if I can't immediately factor it, I'm going to go straight to the quadratic formula. Okay? Because a lot of these, you could spend 20 minutes trying to factor it before you decide, well, I've got to use the quadratic formula. Well, I can see some stuff in this that I think I can factor it. Split up the 5x squared.
That would be 5x. Then x.
Incidentally, it's never 5x squared times 1 or x squared times 5. In other words, you always have to break apart the x squared.
Okay.
What are the signs? The next step.
-4.
No, don't do both.
And 1.
That's where everybody makes their mistake, is they try to get both the full solution in one step. Let's figure out what both signs have to be. They have to be the same or opposite?
Opposite.
So plus, minus, or once again, that's not going to be the same as minus plus. So I have to allow for that, and this is the way I usually do it. Now we're looking for factors of 4. But I can't make any statements like factors of 4 that subtract a 19. Once you have different coefficients, or actually once you have coefficients anything other than 1, then you throw out all of those statements that made factoring easy. And at this point in time, it becomes pretty much a trial and error. Okay, well, here's my factors of 4. Now, normally I tell people to always start with the two factors that are closest together. But I can kind of see that 2 and 2 are never going to produce a 19 in the middle, right?
Mm-hmm.
So I'm not even going to start with 2 and 2. I'm going to try 4 and 1. And in fact, where does the 4 have to be? In the right or the left?
The right.
Yeah, because that 4 better be multiplying this 5 if I hope to give anywhere near 19. Okay, so I'm going to start by trying the 4 there and the 1 there. Does that produce the correct? Now, you know what? Just for the sake of illustration, I'm going to start with the 4 down here and the 1 there. What does that produce for a middle term?
So then negative x and then 20x. and then that'll make 19x.
I get the right number but the wrong sign.
True, it needs to be negative.
So all I have to do is move it up. In other words, I need to put the 1 with the plus sign and need to put the 4 with the minus sign. And that's going to give me the same 19, only it'll be a minus 19, and it'll be correct. Now, the reason I said that was, in other words, there's our answer. But what happens if I were to try 2 and 2? Well, I get plus 2x minus 10x. I get a minus 8x. I don't get the right number.
Yeah, that's way off.
So there's no point in trying that 2 down here and this 2 down there. In other words, we know that 2 and 2 are not the factors we're looking for immediately because it does not produce the correct number. Even though it's the correct sign, the number is the one I want to get correct, first of all. So I can throw out the 2 and 2. I don't even need to try it anymore. And go immediately to the 4 and 1 factors. So you learn a lot from the first trial. In other words, when you guess what the factors might be and you fill it in, it's trial and error. Just start with any two numbers. And then when you figure out what the middle term is, that tells you a lot of information.
Okay.
Okay? All right, Taylor, let's see. You have, that's it for this week? Yeah, I guess it is.
Okay, I'll talk to you later then.
Okay. Have a good one. Bye-bye.
Thank you. Bye.